Hello, grade 9 science. Welcome to day 3, Wednesday, the 25th of March. In this video today, what I'm going to do is just a recap of speed and acceleration. There'll be one more homework Google form on this tonight. So hopefully these examples will help you, and I hope you're doing well with your distance learning. So here we go. So speed and acceleration, just some basic things. Let me put the date up here, stay consistent. So it's March 25th, 2020. And first is going to be a speed example. And the example that I'm going to do with speed is kind of like a trip that has 3 parts. Part A. In part A, a car travels 100 miles. And it does that in 2 hours. In part B of the trip, the car travels 140 miles, and it does that in 2 hours. And in part C of the trip, the car travels 80 miles, and it does that in 4 hours. And just as a reminder, what the equation that we're using when we calculate speed is speed equals distance divided by time. So in each individual part, we can calculate the speed for each segment of the journey. So for instance, the speed in part A is 100 divided by 2, which is 50 miles per hour. In part B of the trip, we traveled 140 miles in 2 hours. So the speed in that part of the trip is 70 miles per hour. And in part C of the trip, we traveled 80 miles in 4 hours. So that's 20 miles per hour. So we have 3 different speeds for each section of the trip. These speeds are actually called instantaneous speeds because those are speeds at any given moment of the trip. But the average speed for the entire trip is based on the entire distance divided by the entire time. So if I want the average speed for all 3 parts, the one thing I can't do is just add up 50, 70, and 20 and divide by 3. The problem with doing that, and the reason why that would not be correct, is because this person who traveled this trip spent so much more time traveling the 80 miles or going 20 miles an hour. They spent half their time going 20 miles an hour and the other half their time going fast. So most of their time was spent traveling slow in traffic. So that's going to bring the average speed down. So the correct way to calculate the average speed is to do the entire distance, 100 plus 140 plus 80, divided by the entire time, which is 2 plus 2 plus 4, or 8 hours. So I think this was 320 divided by 8, and the average speed turned out to be 40 miles per hour. So that was the answer to the average speed for parts A, B, and C. Our second one will be an acceleration example. Acceleration example, and our acceleration example is going to be this. It's going to be 2 parts. The first part is going to be the car starts off moving 20 miles per hour. It accelerates for a time of 5 seconds, and it gets to a final velocity of 60 miles per hour. And the question is, what is the acceleration of the car? So to do this, we would use the acceleration equation. Acceleration is final velocity minus initial velocity divided by time. The final velocity is actually what goes first, so that's 60 minus 20, that's the initial velocity, divided by 5. And we get 40 in the numerator divided by 5. So that would mean an acceleration of 8 miles per hour per second. That means that the car gained 8 miles per hour for every 1 second that it accelerated. Our second example will be this. So part B, this was part A. If the acceleration rate or the deceleration rate for the slowing down of the car, so the car got up to 60 miles per hour, now it's going to slow down. If it slows down at a rate of negative 10 miles per hour per second, how much time does it take to stop? So I want to use this equation and solve for time. So it's going to go from 60 to 0. So I have to reuse this equation. A equals VF minus VI divided by T. It's going to take a few steps to solve this. I'm going to multiply both sides by T. So I'm going to get A times T equals VF minus VI. I want to get T alone, so I'm going to divide both sides by A. And I get T equals VF minus VI divided by A. The final velocity is actually 0 because it says time to stop. The initial velocity is 60 miles per hour. That's how fast it was moving at the end of the first part of the problem. And we're going to divide by the new slowdown rate, which is negative 10. When we divide negative 60 by negative 10, we get a time of 6 seconds. And that's how to use the acceleration equation in a different way. So I hope these two examples help you a little bit on the homework. The homework questions are going to be very similar to the previous 2 nights. They're kind of a combination of both, so a chance to redo them. And if you have any questions, you could email me, and I'll get back to you as soon as you can. All right, thanks.